In this video, we're going to start to talk about volume. But in order to do that, we need to understand what volume is. So I want you to think of a piece of paper. And here is an example of a piece of paper. A piece of paper has length, and it has width, or base times height if you're thinking of that for area, but it has area. Everywhere on the piece of paper that you draw on is part of that piece of paper's area, all on the inside. But turn the piece of paper sideways, and if you do it right, it'll look like this. All you'll see on the edge of that piece of paper is basically a straight line if you see anything at all, because a piece of paper does not really have height, or thickness if you want to think of it in that terms. It's got the top and bottom, but that piece of paper is so thin that there really isn't much between it. So piece of paper is really great to talk about area, but we're talking about volume. Here is an example of a box. Now this box, as you can see here, is really two-dimensional or flat, but I've drawn it so that we can see the sides that normally wouldn't. That's what our dotted lines represent. Sides that are behind something that we can't see if we were actually just looking at the box. But for this demonstration, we can see it. This box has a length, which I like to consider the left to right parts. It has a width, which I consider the parts that are going backwards, diagonally, into the page almost. So this way is our width, but there's still one more dimension that we have, and that's going to be height, up and down. And that's what makes this box three-dimensional, as opposed to that piece of paper, which, while it is three-dimensional, it really looks like it's two-dimensional. So we have a length, we have a length, we have a width, and we have a height. And if we have those three things, we can find volume. Now before we talk about how to find the volume of a rectangular prism, like the one I'm drawing as we speak, so let's give it some width. Oops, that needs to be dotted. Okay, not the best, but it'll work. Now the volume is basically how much stuff can we fit inside of the box. So think about when you've opened up a present. There's usually they come in boxes. Well, the volume is the space on the inside that your toy or whatever is taking up on the inside. So that's what volume is. It's everything on the inside of the box, and it's how much that box can carry. Now, let's talk about finding the volume. Now, the formula for volume is this: length times width times height. And that box that we were working with before is actually called a rectangular prism. It's rectangular because it looks like kind of a rectangle, and it's a prism because it's a three-dimensional shape. If it was just a rectangle like this, we wouldn't call it a prism, we'd call it a rectangle. But since we drew the lines to give it extra depth and thickness, so that it has a width and a height, we would consider that to be a rectangular prism. This is not a great drawing, but hopefully you get what I'm getting at. So to find its volume, all we got to do is take its three dimensions, its length, its width, and its height, and we multiply them together. Now if you notice, I didn't use X's for our multiplication symbols. I used dots. We've talked about this in class before. Dots mean multiplication, and since we're talking about variables right here, because anything could be the length, anything could be the width, and anything could be the height, we don't want to use X for multiplication if we can help it. So let's take a look at a rectangular prism and try to use our formula right here to figure out its volume. Here is a rectangular prism that I have incorporated into our video, and if you notice, it has cubes making up each part. So this will make it easier for us to count and to figure out what its length, width, and height is. And for argument's sake, we're going to say that each of these cubes has a length of 1 inch. So if we count all of these up, we would say that our length equals 4 inches. Because we have 1, 2, 3, 4 inches going across. So we have 4 cubes. Now we've got our length, but remember, volume is length times width times height. That's a terrible multiplication symbol, but you can see what I'm getting at. So we need 2 other dimensions now. We need our height and we need our width. Let's do our height now. Height goes up and down. So if we notice, we have 1, 2, so we're going to say that our height is 2 inches. And then lastly, going backwards diagonally into the page is our width. So we have a width of 1, 2 as well. And now it may not look like it, but because of how we're looking at our picture, this is actually the same length as this. Each of these is a cube, and a cube's sides are all the same length. So we have a length of 4, a width of 2, and a height of 2. So if we plug that in up top, volume equals 4 times 2 times 2, we're going to get our volume for this figure right here. So 4 times 2 is 8, 8 times 2 is 16. So our volume is 16, and since each of our dimensions is measured in inches, we would say that it is 16 inches cubed. We have to use that exponent, otherwise we're not labeling our volume properly. 16 inches cubed, or 16 cubic inches. Let's try another one. Take a look at our rectangular prism now. Try to figure out its length, and remember, length is going from left to right. So what is the length? Well, if you counted up the cubes, you would have counted to 5. So we're going to say that our length is 5 inches. What is our height now? Remember, height goes up and down. We don't include this part up top here, though. It's just a straight line up and down. So the height, if you count those, is going to be 3 inches. And then lastly, we have our width, which is our diagonal line going back. And just like before, it's a width of 2 inches. So now that we have our length, our width, and our height, try to find out the volume. What are we going to multiply to get that volume? Hopefully you're saying to yourself, length times width times height. So it's 5 times 2 times 3, which gets us 30. Now, don't forget our units. We are in inches, so we're going to say that is 30 inches cubed. That will be a volume measurement. Very good. All right, try this next one on your own. Here's a new rectangular prism. Count up the squares and figure out how long the length, the height, and the width are. Pause the video and see if you can figure this out. Also try to find the volume by yourself. So pause the video again and multiply your dimensions together to get the volume. Well, we have 5 cubes going left to right. So we're going to say that these are 5 inches long for our length. Our height goes up and down, which is 2 inches. And our width changed this time. It's got 3 cubes going backwards diagonally. So we've got 3 inches as our width. And if you multiplied all of these together, well, what do you know? It still has a volume of 30 cubic inches, just like last time. It's just that we rearranged our prism to look a little bit different, and that's okay. Shows how we can have different dimensions but still have the same volume. It takes up the same amount of space even though it looks different. Okay, let's do 2 more. Here's our second to last one, and this time we're not going to be working in inches. We're going to work in centimeters. So we're going to say that every one of our cubes is a centimeter, 1 centimeter in length. And the abbreviation for centimeter is cm. So go ahead, find out our length, find out our height, and find out our width. And remember, it's not inches this time, it's centimeters. So find those three things. Make sure you pause the video so that you can do this without skipping ahead. Well, if you counted those up, our length is 5 centimeters this time. Our height is also 5 centimeters this time. And our width, what do you know it, is also 5 centimeters. So what we have here is actually a cube. It's still considered a rectangular prism, but we have a cube because all three of its main dimensions, length, width, and height, are the same length. And if we multiply those together, well, our volume for this guy is going to be 125 centimeters cubed, not inches, centimeters cubed. And what that means is it's going to take 125 of these little cubes to make up this entire cube. Kind of crazy because it doesn't look like there's 125 there, but if we were to take it apart, we would have 125 cubic centimeters. Alright, I know this video is getting a little long, but you're going to try one more, and it's going to look a little different. So this time, our rectangular prism isn't made up of all those cubes, so we don't have anything to count. Now, thankfully, I'm nice, and I'm going to tell you our dimensions. Our length, right here, is going to be 8 meters. Our height, now I'm changing sides for the height because of how I drew it, but it's still the up and down line, so that's still going to be our height. And we're going to say our height is 12 meters. It's a very tall box. And then lastly, our width, which is the diagonal line over here this time, because it's not left to right, it's not up and down, it's going diagonally. We're going to say that the width is, let's go with 4 meters. Use our formula again. Think to yourself, what was the volume of a rectangular prism? It's length times width times height. So find out our volume and do not forget your units. Pause the video and see what you come up with. Well, if I have a length of 8, a height of 12, and a width of 4, we multiply all those together. So 8 times 12 times, actually let's put it in the order it's supposed to be, 8 times 4 times 12, and our total volume, remember, is going to be in cubic meters, because we had meters. So hopefully you've remembered our unit, cubic meters, or meters cubed, and now the part you've been waiting for to see if you've calculated this all correctly. The volume of this rectangular prism is 384 cubic meters. So there we have it. That is how we find volume.